All right, for this mixed review, this is really mostly chapter 6 stuff. It says there's a little bit of chapter 5 in there. Um, but let's just start. I'll erase as I go here. So let's just start with this first problem. It says solve the following differential equations. So when you're supposed to solve a differential equation and you're given a condition, then that means that you need to find the particular solution. So find the plus c. So first we're going to separate. So I would multiply y over to this side, leave negative x over here, and multiply by dx. So I've separated my variables. Now I can integrate. So the integral of y is y squared over 2. The integral of negative x is negative x squared over 2 plus c. And now I like to plug in my condition before I start solving for y. So I'm going to bring this up here. So I plug in 2 for y. So 2 squared is 4. 4 divided by 2 is 2. Plug in 0 for x. So that's just 0 equals c. So c equals 2. And now I can go from my general solution to my particular. So I can say y squared over 2 equals negative x squared over 2 plus 2. So now I can plug in that c. And now you're not finished until you solve for y equals. So let's multiply by 2. So y squared equals negative x squared plus 4. And then we will square root both sides. Now, technically, when you square root, there's a plus or minus. I'm going to make this 4 minus x squared here. There's a plus or minus technically, but remember, you have to correctly satisfy the condition given. So here, y has to come out to positive 2, not negative 2 or plus or minus. In other words, y is greater than 0. So I choose the positive. So the official particular solution is y equals the positive square root of 4 minus x squared. I don't know if you remember that graph. It looks like a little half circle with a radius of 2. Just something noteworthy. Okay, let's take a look at the next one. So ds over dt equals the square root of st. T equals 0 and s equals 1. And then also find s when t equals 9. So we need a formula for s so that we can plug in 9. So when we separate here, remember you can make this radical s times radical t. So I'm allowed to divide by radical s, and then I can leave radical t here times dt. When I integrate this, it might be helpful to rewrite this as s to the negative 1/2. That's not required, but if it helps your brain integrate correctly, then by all means do that. So I'm changing those to exponents. All right, and then I'm going to integrate up here. So when I add 1 to my exponent, I get s to the 1/2 divided by 1/2, or I'm just going to say times 2. When I add 1 to 1/2, I get t to the 3/2 divided by 3/2, or times 2/3, plus c. I'm going to plug in my conditions here. So 2 times 1 to the 1/2 is 2. Plug in 0 for t, so c again is 2. And then I can go back to my general equation. Now I can plug in c. So 2s to the 1/2 equals 2/3 t to the 3/2 plus 2. I need to divide everything by 2. So s to the 1/2, 2/3 divided by 2 is 1/3. T to the 3/2. 2 divided by 2 is plus 1. And this is s to the 1/2, or remember that's square root of s. So you would need to square both sides to get rid of that exponent. So s is equal to, I'm just going to write this as t to the 3/2 divided by 3 plus 1. That quantity is squared. So there's my s. And then I want to find s of 9. So plug in 9. So let's see. 9 to the 3/2. Remember, you should root first and then raise to the power. So this is really 3 to the 3rd. So that's 27 over 3 plus 1 squared. That's 9. 9 plus 1 is 10. 10 squared is 100. So s of 9 is equal to 100. All right, for the next one, it's out of here. There we go. Okay, so for number 3, we need to separate first. So I'm going to divide y over to the dy side, and then multiply dx over to the x side. And now we can integrate. The integral of 1 over y is natural log of absolute value of y. The integral of x is x squared over 2 plus c. I like to plug in my condition now but you can also base e both sides if you want to, but instead of doing that, I just like to do this. So natural log of 200 is equal to 0 plus c. So now I can go for my general solution to my particular. So the natural log of the absolute value of y is equal to x squared over 2 plus the natural log of 200. Now I can base e both sides. This becomes y. I'm dropping the absolute value because positive e to the exponent will be positive, so I don't need an absolute value here. And remember, this will be e to the x squared over 2. Instead of plus ln 200, it could be times e to the ln 200. And so remember, that cancels out. That's the same as saying 200 times this. So I'm going to put a 200 out here times e to the x squared over 2. And maybe it would be easier if you base e both sides here. If you do that from here, it would have been y equals c e to the x squared over 2. And yeah, if you put in 0, you get 200 for c. So either way, I like doing this order, but you could go here and then plug in your initial condition. We should get the same thing. And there's nothing else to do with this. So that is the final answer. All right, for this one, erase what I had here. So this says after t minutes, a chemical is decomposing at a rate of 10 e to the negative t grams per minute. I assume that says. Find the amount that has decomposed during the first 3 minutes. So during the first 3 minutes means we're going from 0 minutes to 3 minutes. And I don't want to jump right into finding the the exponential decay model. If this is the rate, this is like, let's call this dp dt. So yeah, you can integrate this rate and you'll be left with the net change in population or whatever net change in chemical amount, net change in grams, I should say, during the first 3 minutes. So that will be the integral from 0 to 3 of 10 e to the negative t dt. We can do this without a calculator, but it does require u sub. So remember, anytime that your exponent or something in parentheses has a derivative other than 1, you have a little bit of u sub to do. So u is equal to negative t. Du dt is equal to negative 1. So in other words, negative du is equal to dt. So instead of dt, you could plug in negative du, which means that when we set this up, there's a negative integral from 0 to 3 of 10 e to the u du. I think it's worth taking the time to write this out because all these little I almost said chain rule, u sub details can get lost if you're trying to skip too many steps. So what is this integral? This is negative 10 e to the u, e to the negative t. The negative 10 can be outside. I could have pulled that out. Evaluating from 3 to 0. So negative 10 times, so e to the negative 3 would be 1 over e to the third, minus e to the negative 0 is just e to the 0, so minus 1. And there's not really much to do to simplify that. So you could leave it like this, or I'm going to get a common denominator just for the sake of showing that, because often in multiple choice, they will definitely get a common denominator. They wouldn't leave it like this. So they would have something like this. So that's the amount that has decomposed in the first 3 minutes. If you use a calculator on that, you could see, let's see, did I use a calculator? No, I guess I didn't. I should label that though. Good point. Answer key. This should be grams. That's the amount decomposed in the first 3 minutes. All right, I'm not going to bother calculating then if I didn't on my answer key. I think this question came directly from a homework assignment that we had, and this might have been the Chapter 5 thing. It might have been a Chapter 5 homework assignment. So matching. Now, you should be able to recognize exponential growth versus decay, and you're expected to know what those graphs look like. So growth is exponential, increasing. Decay is exponential, but decreasing. So A and C should be easy to pick out. And then for C and D, the way that I matched these next was they have C and D have different y-intercepts. See how this one's at 2 and this one's at 0, or maybe a little below. It's hard to tell on that sketch. So if you can figure out which one has a y-intercept of 0, then you should be good. So y-intercepts are when you plug in 0 for x. If you do that, you get c times 1 minus e to the 0. So c times 1 minus 1, which is equal to 0. The other one, you would get c over 1 plus e to the 0, 1 plus 1. So you would get c over 2, which could be 2, depending on what c is. Find the slope of the tangent line to the graph of the function at the point 0, 1. And here's a little graph here. So slope of the tangent line. So that means here's my y equation. So I need to find y prime, or dy dx. So it's e to the u times u prime. So 2 e to the 2x. And then we just need to evaluate that at 0, 1. The only input is x, though. So y prime of 0 would just be 2 times e to the 0, which is 2. All right, my next one. The value of an item t years after it's purchased is v equals 15,000 e to the negative 0.6286 t. T is between 0 and 10. Draw a graph of the function using your calculator. So I need to type this in to my y equals. So let's see, 15,000 e to the negative 0.6286x. And then I'm going to set the window 0 to 10, and then I will zoom fit. So yeah, it looks exponential here, exponential decay because of the negative exponent. So something like this. All right, part B says, find the rate of change of v with respect to t when t equals 1 and t equals 5. Use your calculator. So because you're allowed to use your calculator, even though you could find the equation for v prime, don't waste any time doing that. The only thing, you do need to show something. So the only thing you need to show is that you're doing v prime of 1. So what is v prime of 1? And then what is v prime of 5 going to equal? So if you already have this typed into your y equals, then on your home screen, you can do math 8 for derivative. You can just type y1 in here, alpha trace y1. Evaluate at 1. So I'm going to write that down. So that's, split this. So that is negative 5,028.84. We're talking about money, right? The value of something. So I'm assuming that's in dollars. So let's say dollars per t was years, dollars per year. So at the first year, that makes sense. The value of something drops the fastest in its when it's early on. So during that first year, it's dropping pretty fast. And then all I have to do is go up here and grab this again and change the 1 to a 5. And still the value is decreasing, but at a slower rate. So negative $406.89 per year. I'm only rounding to 2 places because it's money, so I'm rounding to the nearest cent. Okay. This one says no calculus needed. So, okay, so this is just, again, more pre-calc review. Suppose you open a savings account in which the interest is compounded continuously. Reminder, that is the PERT formula, A equals PE to the RT. If you invest $1,000, that's your principal, at an annual interest rate of 6%, R is 0.06. It's a pretty high percentage there. Find the amount after 10 years, use your calculator. And then how long will it take to double your initial investment? So for part A, how long after 10 years? So again, I think we had something like this in our homework as well. So A equals 1,000 times e to the 0.06 t, and t is 10. So let's see what that comes out to. So that's 1,822.12. That's how much money after 10 years. How long will it take to double your investment? So now, because I know I'm investing 1,000, I can put 2,000 here, but really it doesn't matter. Actually, I'm going to erase this. It doesn't matter. Whatever your principal is, you're just saying double the principal. Your first step, no matter what, if you're solving this algebraically, is to divide by P. So you're always going to get, if you're doubling your investment, you're always going to get 2 equals e to the 0.06t. If it said triple your investment, this would be 3, quadruple, 4, etc. Okay, so how do we solve this algebraically? We natural log both sides. The natural log of e to the 0.06t is 0.06t. Divide by 0.06. So t is about equal to natural log of 2, oops, not 22, natural log of 2 divided by 0.06. So 11.552 years. So we're doubling our money in that time, okay. You could also solve by graphing. You could have said 2 and e to the 0.06x, and I would just maybe zoom fit to start. And if you don't see the intersection on there, or sorry, not zoom fit, I would maybe zoom 6 to start. And then if you don't see the intersection on there, you bump your window out just a little bit. Maybe this goes to 15, maybe 0, and then I hit graph. And the calculator can find, the calculator can find the intersection point for you. So same answer. And if you did that, then you just need to show your equation and your answer. All right, let's look at this one. So how much of this pre-calc type stuff are we probably going to have on our AP exam? Maybe problems like this where they give you 2 data points and then you have to come up with the exponential function. So this says 4 months after it stops advertising, a manufacturing company notices that sales have dropped from 100,000 units. That would be when like t equals 0. Dropped to 80,000 units per month, and that's at t equals 4. If the sales follow an exponential pattern of decline, what will they be after another 2 months? So after another 2 months, 2 months after 4 months, that'll be when we plug in 6. So we still don't need calculus. We need pre-calc skills. So we have these ordered pairs to work with. 0, 100,000. And then we have 2, oh no, not 2, sorry. We have 4, 80,000. And then we're trying to find 6 and whatever that's going to be. So now the 0 is the initial, and this pattern of exponential decline, that's like, let's see, what are we talking about? Sales. So I'm just going to call it y, whatever. So y is equal to some c value times some e value to the negative kt. That would be an exponential decline. And or you could also just say like a times b to the t, and you're going to get a b value that's a decimal less than 1. But anyway, so when y is 100,000, t is 0. So c is 100,000. And whether you show the work or not for that is up to you. And then when y is 80,000, I now know that c is 100,000. And that happens when I plug in 4 for t, so negative 4k. All right, and then when I divide 80,000 by 100,000, so that's 80 divided by 100, 8 divided by 10, that's 0.8. And then I can natural log both sides and divide by negative 4 to get k. Let's just see what that comes out to. Natural log of 0.8 divided by negative 4. Now, and if you have the negative built in like I do, you get a positive k. But when you go back to put it in the formula, it's going to be, let me just go ahead and write my formula here. So what is my formula? My formula is y equals 100,000 times e to the negative k, which is ln of 0.8 over negative 4. So that's just going to be positive, right? Or no, wait, negative. Yeah. So negative, actually, here, let me write it like this. To the negative 0.0557 t. And then I want to plug in 6 into that. So I'm going to just recall this number here. So when I type this in, it's 100,000 times e to the that times 6. Oops, to the, I forgot my negative sign, didn't I? Negative. There we go. Okay. And yeah, because our sales are dropping, right? So we're going from 80,000 down to 71,554. Okay. So that's going to be, I'm going to round to the nearest sale because we're talking about sales instead of having 0.175. So I'm going to say sales. I guess it's sales per month. Not that this is a rate, but everything was measured in each month. So, okay. And then let's take a look at the last problem. So I don't know if you've noticed, but ever since we kind of got through chapter 3, a lot of the free response questions involve finding equations of tangent lines, finding relative extrema, finding points of inflection. And I just realized I found the relative extrema of this. I didn't actually check for I guess we can't find, this does mean relative because this is not a closed interval, so I can't really find the absolute extrema because there aren't endpoints to plug in. So anyway, that was meant to be relative. Okay, so how do we find relative extrema? So this is something you should be studying if you have to pause and think about it for more than like a second. Relative extrema is first derivative, critical numbers, put it on a number line. So let's find f prime of x. I need product rule to do that. So there's another thing to remember. So first times derivative of e to the negative x, which is negative e to the negative x, plus second times derivative of x, which is 1. To get critical numbers, we set this equal to 0, and we have some factoring to do. So let's factor out an e to the negative x. That would leave me with negative x plus 1. So do you get any critical numbers when e to the negative x is equal to 0? No, that's never equal to 0. But you do get when negative x is equal to negative 1, x is equal to 1. So put 1 on a number line, test into f prime, and see what's happening with f. So I'm going to plug in 0 to start. It's probably best to plug into your factored form here. So e to the 0 times 0 plus 1 is 1 times 1, which is positive. And then maybe plug in 2. E to the negative 2 is just 1 over e squared. And then when you plug in 2, you get negative 2 plus 1. So that's negative. So f changes from increasing to decreasing. That means that there's a relative max at f of 1. So when I plug in 1, what do I get for f? I get 1 times e to the negative first. So 1 over e is a relative max because f prime changes from positive to negative. On the real AP test, please write the words positive and negative, but I'm okay with you abbreviating for our homework and quizzes and tests and stuff. All right, what about the other part? Points of inflection. So that should, again, automatically in your head be like second derivative, put possible inflection points on a number line, test intervals. So second derivative, I'm going to go off the factored version of f prime. So f prime was e to the negative x times, let's just do like 1 minus x. So the second derivative is another round of product rule. First times derivative of the second plus second times derivative of the first. Set this equal to 0 and see what the possible inflection points are. So let's factor out, they both have this negative, so let's factor out a negative e to the negative x. That would leave me with 1, and then plus 1 minus x. right? Because this negative canceled and that negative. Okay, yeah. So this is negative parentheses 2 minus x. The e to the x could go down here if you wanted to. You don't have to do that. I didn't on the first one. There are no possible inflection points from setting e to the x equal to 0. You do get x equals 2. So that needs to go on a number line and test into f double prime. So let's see. If we plug in 0, we get negative 2 minus 0 over e to the 0. That's negative 2 over 1. That's negative. And if we plug in 3, we get negative parentheses 2 minus 3 over e to the third. Negative negative 1 is positive 1, so that's positive. That means that f changes from concave down to concave up, which means that's a point of inflection. So when I plug in 2, I get 2 times e to the negative 2, or 2 over e squared. So 2 over e squared is a point of inflection because f double prime, you can just say changes signs. It doesn't matter whether it's positive to negative or vice versa. All right, that finishes it. Finishes this review. We also have an AP Classroom you could be working on. Our 2 free response questions are not calculator problems. So then that should lead you to believe that Euler's method is most likely on the calculator part. All right. Please come into office hours if you have questions or want practice on any of this.